Hello and welcome to our new video, how to extend vCAC using VCO. In that specific use case, we're going to reconfigure virtual machine because the CPU configuration is not matching our needs. So we use VCO to automatically reconfigure every single deployed virtual machine from a CPU perspective. My name is Matthias Eisner. In the comdivision group, I'm the director for cloud and management. All right, let's get started. Just to demonstrate the use case for this specific video, we're just connecting to our vCAC infrastructure to the catalog, and we're going to deploy a CentOS virtual machine. So we file a new request, and then we are going to increase the number of virtual CPUs for that newly created virtual machine. So we're just using our comdivision lab infrastructure to showcase everything. If you need to know how to create or build that lab, just go to the other videos in our channel and then you can recreate or build your own lab infrastructure like that. So we're increasing the number of CPUs, and now we're going to create or deploy a new virtual machine using vCAC. So the request is submitted and off you go. In the meanwhile, we're going to prepare our infrastructure. So it takes 2 or 3 minutes for the new virtual machine to be deployed. So to prepare the environment, we go to Orchestrator. So we added the vCenter server instance shown in the previous video. So we were able to use the vCenter SDK, but we are now going to reconfigure vCAC using VCO. So we are using the built-in VCO instance, and what we have done for preparation, we already added the vCAC host to Orchestrator, and the next step is we need to configure the extensibility. So we need to, let's go for installation. That's fine. So we're going to install the VCO customization for all the state change workflow steps and everything else into the vCAC. We just run the workflow. We select our vCAC instance, and the next step is we add all the workflow stubs to vCAC that we're able to add workflows to a blueprint, and then we can choose how many additional menu entries are going to be created for the virtual machine. So I just choose 4. So the workflow starts running, and now VCO is going to reconfigure vCAC so that we're able to use our new workflow. In the meanwhile, the new virtual machine is going to be created. In our case, it's a DEV-006, and if we take a closer look to that virtual machine, okay, it's still in the deployment process, so give another couple of seconds that we're able to view the settings of that virtual machine. Again, we have chosen 2 vCPUs for that specific virtual machine. So, alright, here we go. So we can now take a look to the settings, and if we go into the settings of that specific virtual machine, we choose CPUs, and that's the issue. We see 2 sockets and 1 core per socket, and that configuration won't change in the future. So it's not an issue, not a big issue for a virtual machine with 2 vCPUs, but think about 8 or 12 vCPUs. So you have 8 or 12 sockets, 1 core each, and so you can't use the wide VM NUMA feature from vSphere. So the idea is that we're automatically going to reconfigure that specific virtual machine. Alright, so how can we do that? First of all, we need to prepare some additional actions which are going to be used within VCO. Therefore, first of all, we need OnyX. So I prepared the web page. Just go to Google and search for Fling and OnyX and download OnyX. Right, I should have agreed to the download to the user EULA. So we have downloaded the OnyX. And another thing, I will explain that in the future. So you can download a special action for VCO from the communities. So there is the URL, and then here we go. You can download that file, which is an action. All right, so we have downloaded those two files. So VCO is still running. So we go to the downloads. We have these two zip files in here. Right, perfect. So we're going to extract it to the desktop. Right, perfect. And we need to extract that one as well. Off you go. Perfect. Now we're going to add, so we have installed the VCO customization vCAC, and now we're going to add some actions to our VCO. Therefore, we create some folders. So I really like or enjoy creating a folder which I name com.library.vcac.helper. So that is a folder which I use to add helper actions for the VCO to work with vCAC. So we are going to that folder, and now we add that action to that specific folder. Off you go. And we need to create another one, especially for OnyX, because OnyX is using a special type of an array, and that is delivered with OnyX. So we have extracted OnyX, we navigate to the folder. There is one folder called extensions, and that one is specially for VCO JavaScript, and there is the array.action. So we import that one as well. So for that folder, it is very important to be named com.vmware.onyx. Just go to the README file. It documents that exact behavior. So we have added those two actions. Right, so our virtual machine is deployed. If we navigate to to the vCAC and we go to the items tab, we see the newly created virtual machine, the dev-006 VM. And so there's the machine, and there is no further reconfiguration done right out of vCAC. So we are going to change that specific behavior using a VCO workflow. Again, that virtual machine, settings, check the CPUs. So we have 2 sockets, 1 core. We're now going to create a workflow to change the virtual machine configuration to 1 socket with 2 cores. So we go to VCO, right, and now we're going to add a new workflow, new workflow. Here we go. Change CPU configuration. Great. All right. So the first thing we need is just go to actions, QC, it's QC, not QV. Drag and drop that action, setup. So we get a vCAC VM object of the type vCAC virtual machine. That is a complex object. So if we go to the vCenter using the SDK, we can't use that object anymore. So that action just grabs the vCAC virtual machine object and converts it to a VC virtual machine object. So that's the only thing done by that specific action. So we promoted all the stuff we need. Next step is, we're going to use the provisioning stub. So we need to shut down the virtual machine. Therefore, we have an action, wait for the tools. So we just waiting for the tools. So we have virtual machine as an input, and that is already a virtual machine object. So we are going to add some values. So we pull every 5 seconds for the VMware tools, and then we can configure a timeout. Then we promote these values as well. So if the tools have successfully started, we're going to shut down the guest OS. So shut down guest OS and wait. So we add that workflow that is predefined. Again, we have virtual machine as an input. We promote that. The next thing we need is a scriptable task for the reconfiguration. And last but not least, we need to restart the virtual machine, of course. So we need the start virtual machine workflow, right, which has a virtual machine, and we skip the host because we don't need that. All right, so that's the basic workflow to reconfigure the virtual machine. Now we're going to edit. First of all, we're going to generate two inputs. We need to push that input parameter to an attribute. That attribute is used throughout the whole workflow. So we're checking the visual binding tab. So we have the virtual machine attribute bound to that. That looks great. So we check that action. So here the output, the action result is still set as an output parameter. So we need to redirect that to the attribute to have the virtual machine. Perfect. So checking, binding, we're using the attribute. That looks great. Checking that workflow, the visual binding tab. So again, we use the attribute because we don't need to pass the virtual machine object from everything to everything. So we need to bind that attribute to the scriptable task because we're going to reconfigure the virtual machine object. So that is bound. So off we go. We're going to add some JavaScript in here in a couple of minutes. And last but not least, the start virtual machine binding. All right, off we go. So that's kind of an add all the needed input parameters to the steps of the workflow. Great. There's just one big question left because we need to add JavaScript code to the scriptable task. How can we get that code? That's the step when we're going to use OnyX. First of all, we shut down the virtual machine. So we shut down the guest OS. We close the vSphere client. Then we're going to use OnyX. Right, OnyX. So just start OnyX. OnyX is kind of a proxy which grabs all the API calls sent from the vSphere client to the vCenter, and OnyX has the ability to output those as VCO JavaScript code. If you don't know that behavior, so that's pretty cool, use OnyX. It's an awesome tool to get all that stuff. So we need to connect to our vCenter server, and of course we're going to launch the vSphere client. We need a username, a username, and the password. Right, so vSphere client is starting. Yeah, that's fine for us. So now OnyX is acting as a proxy and is capturing all the API calls sent from the vSphere client to the vCenter server. And that is a really cool trick to get all the VCO API calls, so to get some JavaScript. So what we're going to do now is we switch to OnyX and we start OnyX. Perfect. So now it's running. Now we are going to reconfigure the virtual machine, so you can change everything in the virtual machine. So we're going to the CPUs. We're changing to one socket with 2 cores. Click OK. So the virtual machine is reconfigured. And if we now switch back to the OnyX window, we see we have the API call. So we can pause OnyX again. And now we are going to copy. All right, copy and paste that to our JavaScript. Paste. Off you go. Perfect. So that is not a new variable, so it's just used in here. We can delete that line. And very important, because OnyX is dealing with something called a managed object. In our case, we are passing the virtual machine object, which is a complex object of VC virtual machine. We are grabbing that virtual machine for the scriptable task. So we're going to change that to the name of our attribute. So it changes to magenta. So that is kind of an indicator that that object exists. That's it. So we are reconfiguring the code. Perfect. So we have created the workflow, done in, let's say, 5 or 8 minutes. So save and close. That shows us that the validation is not successful. We're just checking what's happening. So we have from that first action, there is the action result, but we rebinded the action result to our attribute. So the output parameter of the workflow called action result is no longer in use. So we can delete that parameter. Perfect. Now save and close. We increase our workflow version. Fine. Next step, we need to add that workflow to the stub of our blueprint. Therefore, we have in the vCloud Automation Center library, so we have installed the customization. We assigned the state change workflow. So we need to assign a state change workflow to a blueprint. So we use VCO. In our case, we're going to use the machine provision stub. We select our vCAC host, that is our vCAC instance. Select. Next, we need to map the blueprint. So we need to insert the value. We can browse the vCAC repository, go to the blueprints folder, and the CentOS 6.4 small, that's our blueprint. Add, select. So that's the blueprint. So we're not going to apply those changes to existing machines. And the end user workflow to run. Now we need to select our newly created workflow. So it starts with change CPU configuration. So we can add workflow inputs as a blueprint property. So that would be a new custom property in the blueprint. We don't need that stuff. And we can add the last workflow run input to the blueprint property as well, but we don't need both of those configurations. So off we go. So the workflow is now going to reconfigure vCAC. Done. Perfect. If we switch back to vCAC and navigate to the blueprint, blueprints, we can see that specific configuration change being attached to our blueprint. So it's kind of a new custom property. So that is our blueprint. We edit that one. Right. Give it a sec. So if we now go to properties, we see external stubs, machine provision. So that is the custom property needed for the blueprint. That actually allows that the workflow is going to be executed. So these are all the prereqs. Now we're going to check if it's working. So we're just going to the catalog and request a new 6.4 CentOS virtual machine. So we increase the amount of vCPUs and we submit a new virtual machine. Awesome. Right, so now it's going to take a couple of minutes for the new machine being deployed. So we are going back to our workflows to watch the run of that workflow. We see we don't have any token right now on that specific workflow. So in the first run we will have that specific token. We're going to observe the provisioning of the new virtual machine using the vSphere client. So again, the whole idea is you can reconfigure automatically every virtual machine using OnyX and just use the provided way to grab the VCO JavaScript code. It gives you the ability to reconfigure everything inside the virtual machine automatically for every virtual machine which is provisioned right now. I know, speaking about 2 vCPUs, vNUMA is not kind of an issue, but if you have virtual machines with 8 or more vCPUs, that might be an issue. So you can reconfigure those virtual machines to have 2 sockets, 4 cores each, to either leverage the virtual NUMA capability of vSphere, or if you have some licensing issues, if the software is licensing to the amount of sockets and cores. Here we go. So the new virtual machine is created. In our case, it's a dev-007. So the files are copied, and during the first start of virtual machine, we're going to check the settings. So we are going to edit the settings, go to the CPUs, and then check. And we will see that that virtual machine again has 2 sockets, 1 core each. And after the provisioning, the virtual machine is going to be shut down, and VCO is going to reconfigure that virtual machine. All right, let's check settings. So that's the dev-007. It's CPUs, it's 2 sockets, 1 core each. So I cancel that, and vCAC is going to customize the virtual machine. Then it is initially powered on. After the power on, the virtual machine changes to the machine provision state, and that's when VCO is going to kick in. So virtual machine is started, and now we will see that the workflow starts running in around a minute or 2 after the virtual machine has changed to provisioned. So right now it's booting. You can again, for example, you can do that within the template which you use for vCAC. For example, if you need to reconfigure the virtual NIC to have kind of a VMX 3 adapter instead of an E1000, you can add additional SCSI controllers, use the PV-SCSI instead of the LSI logic SAS or parallel, depending on the guest OS. Now we see we already got a token, so the workflow started running. So it is running. So the first step is shut down guest OS. In vSphere, we see the task initiate guest OS shutdown. That's a graceful shutdown. So the virtual machine has been reconfigured and it's powered on. So we can see the workflow is still running. So It's starting. So the workflow we use to start the virtual machine waits for the VMware tools to be started again for a successful run. That's pretty cool if you need to add additional steps at the back of the workflow or at the end of the workflow, so that you can make sure that the VMware tools are up and running, that you can reconfigure the virtual machine. So we have a successful run. And if we now go back to the vSphere client and check the settings of that specific virtual machine, in its settings CPU, you can see we have one socket with 2 cores. So I think that's a pretty cool use case and a pretty cool example on how to use VCO to extend the capabilities of vCAC and to reconfigure virtual machines exactly matching your needs. All right. Thanks for watching, guys. Have fun extending vCAC. See you soon in one of our next videos. Bye.